Here we are. Welcome to day 3 of Weekends Web App, the stream where we're coding a complete web app from scratch on the stream. No code that won't be done on this camera. Anyway, thanks for coming by. We're going to get straight into it. This is day 3, as I said before, so if you were following along with the Git repository, you can get to the code right where it is right now using git checkout day 2. Anyway, let's talk briefly about where we're at, and then we'll talk about where we're going. So last time we needed to set up our router a little bit further. So we just run this up. So if we run up our server and take a quick look at where things are at on the browser, we needed ourselves some routing. So routing, the simple act of changing what page we're looking at, and we've got it set up so we can click any link and then the app will load that particular view. And we've also got to the point where we can have parameters for a particular view. You can see here we have 3 pages, and all technically these are the same view, but they have a different parameter. So one is entry 3, one is entry 2, one is entry 1. And you can see that in the URL bar, but also here in the actual view itself. So this sort of forms the baseline of our view system as it stands, but that's not really enough to handle routing once we start to get more complicated cases, because we have the entire concept of because eventually each of these routes it'll need to go out and get some sort of information, and it won't always happen immediately. So having the router just assume that everything's going to be ready for it straight away is just not enough. So at this point, we need to do a little bit more with our setup in order to set things up properly. But before we do that, what I would like to do is just take a moment to introduce some sort of testing into our system, because we're starting to write code that we're going to have to depend on over time, and I don't want to have to I want some easy ways to test some cases, so I'm not jumping back and forth between the browser and the code, because for some things I just want to run them with a test, a very simple test or something like that. So there are a lot of testing frameworks out there, and we could spend hours just working through and getting our testing right and stuff like that, but I don't really want to do that. So what I'm going to do is refer to Facebook's fairly recent testing framework called Jest, not just, Jest. There we go, delightful JavaScript testing. We will see if that is in fact the case. And what we want to do is just have some setup so that we can write some tests pretty close to where our code is, and just check whether things are behaving as we expect them to. We are not going to go whole hog trying to get full test coverage or anything like that, especially in this early stage, because it's important to understand with our code as it stands, we are in an exploratory phase. We're trying to get to a point where we can find how it is that we want all of this code to work, so that we can gradually work our way towards something that is then going to be our final solution. There's not a lot of point in writing heaps and heaps of tests to verify that things work as they do now, because we're just going to change it and have to rewrite the tests as well. But it's still nice to have some tests so that we can sort of understand where our code is and make sure that the bits that we do sort of want to leave around, that they do actually behave as we expect them to. So what we're going to do is going to get this testing framework up and running for us. Now, we need to use it with TypeScript, and unfortunately, even though TypeScript has a fairly solid ecosystem around it, there's always packages that we need to go to depend on that are beyond the basic use case. So we'll just follow these instructions here and see if we end up with what we want working as we expect it to. So first off, now I have had some feedback that I should just pick one package manager, because Yarn and NPM both serve the same purposes. So I'm going to do exactly that, and I'm going to pick one, and the one that wins is Yarn for me. So we're going to be using Yarn each time for our package management and general NPM style things. All right, so we're going to add the development dependency TS Jest, which is TypeScript Jest, and we're also going to add the types for TypeScript Jest. And we're also going to add Jest itself. So we'll chuck all them in. Let it kick on over, do its thing. And now, apparently for testing of Jest, all of its test stuff lives in package.json. So we're going to copy this over, just use it as is, and see if we can get things to behave as we expect them to. And I believe when we run it on scripts, we're going to simply run Jest as is. We'll get rid of that. And we should be able to just simply run yarn test to get what we want. Might not be true. Okay, so it's found no tests, but it seems like everything is working as expected here. So let's put in some basic tests here for our routing. So let's think of some basic ones to the match here. So this match path to route seems like a good candidate here. So we will open up client, platform, routing, and we'll make a routing.test.ps file. Now, as I've never used Jest before, I'm going to refer to its documentation to see if we can get the right setup here. Okay. So it seems to be that we should be able to just run these functions like test and expect and whatnot, and just assume that they'll work. So let's give that a try. We'll just run a test and we should literally just go, does this work, to start off with, and we'll go from there. Do the obligatory console log to see if that actually picks up. Alright, well, according to that, it does work. Very good. Alright, now let's actually test the routing function, as it were. So we're going to export this function so that we can test it. And I suppose we'll export the function of update view. I really don't mind sort of just exporting everything, even though it's technically not necessary. By exporting things, we can, because we've got TypeScript, it's really kind of safe. We don't need to privatize every variable. We're not in this huge enterprise scenario where we want to make sure no one touches particular parts of our code. So I don't feel at all bad about doing that. Anyway, so we need to bring those functions in. So if we import, say, because we're only going to test, what's it called? Match path to route for now. And we'll pull that from the index. And what we want to do, yeah, so we're going to get view params out if we give it a particular string. So let's just test. So match path to route works on parameterized, parameter-free routes. That's what we'll test to start off with. So that will give us a matcher of some sort of parameter-free route. So it's simply let's go about, and then we've got the path. The path to match is also about. We'll give them both trailing slashes because that's our expected behavior. We don't really need to test the edges right now. And look here, so we should be able to feed it that. Simply go so constant view params. So we're supposed to get view params out of this function. Yeah, if we feed it that, then we should either get an object or null. In this case, we should get an object. So let's see what that, how we assert that with our test. Well, expect anything seems to be fine. could expect anything there. Yeah, expect, right. So our expectation is that view params to be truthy. Yeah, let's go truthy. Let's run that test and see if it actually passes. So that's good. We've got something real simple there. So match path to route returns null when there's nothing. Yep. So what we're doing is like just establishing some basic behavior that we expect to happen, and then we'll do a bit more than that a little later. All right. So if we've got a matcher of ab and the path is this, then that should be falsy, or it should be null. So that expectation, in fact, it's really nice that we've got TypeScript here, because it means that we can do stuff to be null. So that's our test there, both of which passed. And then we'll just match out on parameters. Match path returns null when no match. And then finally, returns correct parameters. Yeah, returns correct parameters, and this uses this whole concept of entry slug, or rather slug. So now we have a little test in place that refers to this concept of matching as well. So that should cover us for our matching purposes. I mean, it could be really easy to break this down the track. So this will give us the means to change it to something like regexes if we ever want to, and be sure that our matching functions are still correct. So if view params to be equal to, well, let's see if it does, if it matches the different objects properly. And I'll explain what I mean by that in just a moment. Yes, okay. So this is an interesting quality of JavaScript that we may as well talk about now that we're testing it. So you can see here, it expected this and it received this. And it's using shallow equality here. So to be is shallow equality. And you can see here, compared values have no visual difference. Note that you're testing for equality with the stricter to be match you're using object is. For deep equality only, you use to equal instead. Because while these objects look exactly the same, they are not the same object, because this is JavaScript. And because of that, they are not referentially equal. And even if you were to do something like, say, like a statement, such as this, these would never return true because these are not equal. Yeah, those two statements are not equal because these are different objects. And the only way you can compare objects is if you have something that goes a lot deeper and tries to match them via equality. So it actually goes into each of these properties and then compares them against one another. So it actually takes a lot longer to compare. And this might sound like a pain in the butt, but and it can be if you expect it to be the case that these are equal, but it actually becomes quite useful once you start to get down the road of rendering and re-rendering your web app, because you can use this shallow equality as sort of a way to if you're very disciplined about how you change things, you can use it to be quite efficient. But that's sort of getting ahead of ourselves. So for the moment, just understand that every object we create is a new one, and that equality, by figuring out whether they're equal, they have to be something, you have to either deeply compare them or they have to literally be the same thing. So something like So if we were to compare it this way, they would in fact be equal because it's literally the same object. Anyway, let's carry on. Now that we know that our test should run in this case because we've used toEqual, which will use deep equality checks, then we're good to go. So we've got some basic test suites. We're actually going to dust that off though and leave that be, but I just wanted to introduce some tests because testing is hard and there's lots of different ways to test your programs and all that sort of thing, but if you want to be able to test your code, it's important to start testing your code early, because that way you can figure out whether you can actually test your code, because there's certain things that you won't be able to test if you leave them way too long to actually introduce any testing. But for the moment, I'm happy with that. I don't feel the need to do anything further there. So we're just going to make a commit now that we've got some tests, and then we'll talk about our next little bit of work. Right. So when it comes to views, I've sort of become a bit opinionated about this stuff. In fact, I'm a bit opinionated about a lot of things. But with this one, it's been borne out by my experience that while it is easy to set up certain things like React Router and have things happen immediately when routes change. So when the URL bar changes, you immediately end up somewhere else. But the reality is sort of loading new pages doesn't work like that. If you think about what it's like when you click a link on a web page, when you click that link, the first thing that happens is you tell the server, I want that page, right? And then the server does things. It loads up your assets. So there is time that that passes in this position. And then after that time passes, they will start to give you back the view. And it will come in little bits and pieces. I mean, you usually won't see this, but it will be streamed down, and then eventually the whole page is loaded, and then finally you've got your JavaScript, and in fact your CSS would load early here. But either way, the whole point is this doesn't happen immediately. There is very little times where you load a new view immediately, where you actually have all of the things that you need right then and there. That is not even true for the offline application that we're intending to build. And the reason for that is because whenever you end up interacting with IndexedDB, that is asynchronous, which means you'll have some code. So say the view wants to load. We've got a particular view, and I'm trying to find the right sort of stuff for this sort of tablet writing. This is a pretty old tablet, and it's feeling a little bit splashy, but hopefully I can bear with it and work through this. So with the concept of a view, when you load it, you can't just immediately render it. Because say we have a series of entries that we need to load into this page. We don't actually have everything that we need. And usually what will come first is you'll have your view. So you'll have a name for the view. So let's say it's the entry view. And we'll have some parameters. So that might be a name or a slug or something like that. So you've got a slug. And usually what needs to happen before you can actually render this view here is you need to go and collect the actual slug. Collect the actual entry. So if you think about the database down here, so while we're in the middle of loading, and hopefully this, yep, it does it, good. So while we're in the middle of loading, so we enter here, and then we need to do some sort of logic here, some sort of loading logic that tells it, all right, so we've got some entries in here, and based on, so we've got some entries in here, and based on that, that's getting to be a bit annoying there. There we go, I'll let go. All right, so based on this slug here, that's going to match against somewhere in here. So say we've got just the letter 1 for our slug. Sorry, the word 1. And this is 1, this is 2, this is 3. So every time we end up at this page, we need to make sure, let me find another color for it. Every time we visit this view, we need to, before we can render the view, we need to make sure that our in-memory storage has this. So when we arrive there, there's probably going to be some logic that loads up and says, all right, I want you, the database, to get this and put it over here into in-memory. Only after that's done can we then begin to load the view. Because once it's in memory, our view should be able to render the whole lot with no problems, because article 1 is going to end up in this view here. Or entry run, rather. So what that means is that our routing system has to have some concept of the fact that it's going to be loading to the next view or the next route or whatever you want to call it, and then getting some sort of success or failure after it does it. Now the other thing is when this happens, because we don't actually know if we have this data yet. Let's say we were visiting somewhere that was 4, okay, entry 4. Well, we don't see one here, do we? So what we would have to do, let me think, there we go. What we would have to do, we try and hit up the database, we find that we don't get it, and then at that point, we throw back an error. Some sort of 404 error. So if you're not super familiar with websites, of course, the 404 error is the not found error. It means it didn't find what it was looking for. So that passes back up to the view function or something like that. So instead of ending up at this view that we wanted, we end up at some sort of 404 page. Because remember, we can't depend on the server to give us that 404 page. So instead, we need to do it. We need to implement that concept of a 404. What else bad could happen here? What if there was some sort of server error in the middle of this, or some sort of server error, or what else could it be? It could be your access is forbidden or something like that. So there's a few other errors. So 403 or 500. This one here is access forbidden, and 500 means server error. Essentially anything that starts with a 4 means that it's the user's, well, not necessarily the user's fault, but rather the front end's fault. And usually 5 and above means that it was the server, the back end server's fault. But either way, we need to handle bad cases, we need to handle good cases, we need to handle the cases that are delayed. So this concept of loading means that it takes time to get where we want to go. So I'll just keep that up there. Our ideal loading system, if we start from left to right. So if we're on a view, and we have a series of links all over this page, and we click one. All right, what happens from there is it goes to the router, and it says, hey, give me that route, give me that view, give me that function based on that path. And it could potentially, if no route matches, then we can immediately 404, because we know that it's not matching any page. So that's one alternative. So we have our if we have our bad cases down here, then that ends up there. But if we do find it, then we need to start loading our view. And there are 2 steps to this. So if we jump on in, and first we talk about preload or pre-render or something like that. But let's use the word preload for now. So we know that all the information we've got is what route and any parameters of that route. And during this preload process, it might be immediate or it might take some time. We don't know what it is. But either way, we know that it's going to take, we know that we have to wait for the go-ahead before we can actually render the view. So we'll go ahead and we'll have to be like every viewer is going to have to write some sort of function here, some sort of preload function. Even if that preload function is literally yep, everything's good, go ahead. That preload function is going to give us a way to, that preload function lets us pre-populate our in-memory system and get us ready. And like obviously we won't need it in this early case, but we do need this system in place in general. So we may as well make a start on it. Once that preload is done, then we can actually do the render of the new view. And I don't like how this one drags. Yeah, it's doing it again. There we go. Anyway, so once we've got the route and the parameters, we should have everything we need. So those route and parameters keep on going. And in addition to that, we'll have the in-memory data available that will feed into that as well. Now, the other things that can happen, so we can have some bad cases here. Let's see. We can have some bad cases here where, say, it didn't find the data it needed. So it could 404, or it could 500, or 403, or whatever. It could be denied in some way, shape, or form, and then have to backtrack to these error pages. Let's just, oopsie daisy. And let's just say that we've got all those covered. All right. So that is what kind of system we want to load our new things, rather than doing it all synchronously. We want to be able to have 404s, and we want to be able to do this sort of preload concept, so that if we end up with misses, we can end up going back. If it ends up taking time, it just works. It smooths it over, and it doesn't do anything wrong while it's happening. What's going to happen? And there's one other thing to keep in mind, and it's what does the user see? That's an I, in case you didn't realize. What does the user see from this point all the way up to here? And this is where, I mean, it's a partial user experience thing, and it's also a partial, like, what is the best way to handle loading? Because, I mean, what we could do as a general rule is maybe we just provide a little spinner. That's a really bad spinner. But anyway, let's make it a circle, right? So what we could do is just provide a spinner all the way until it gets to here, and then we load it. And maybe we fade the view down, we provide a spinner, and then we animate that spinner all the way until we get to this new view that's being rendered. Because that's a potential way to handle it. Once we get further on, though, we might want to be more gracious about how we transition. Because just to talk on that just a little bit more, you can make your app seem like there's no loading at all if you figure out a really nice, like you've also got to have a fast server, but what if you also have some really nice transitions in between each of these stages? Because if you have something nice happen between, say, 0 seconds and 0.5 seconds, potentially all of this stuff can happen during those 0.5 seconds, and your user doesn't have to know about it. And yeah, it can help smooth over a lot of the rough edges if you do transitions really well. Now, I think the last thing I'll talk about is just how rendering, I'm very deliberate about doing this rendering step last. and making sure it's contained in some sort of function or some sort of concept of a function or something like that. Because I don't want to have to worry about sort of top level framework concerns while I'm in the router. I really just want this to be code, because that way I can write transitions with just raw JavaScript when I need to. I can just do raw CSS transitions if I need to. Like there's a lot more flexibility there than if I have to wrestle with React and make sure everything works at every step of the way across to here. So that's just sort of why we're going to try and contain sort of our bits of code, so that this routing as a concept will act as containers for the rest of the page, rest of the application. But anyway, that's probably enough time on the whiteboard. Let's get into the actual coding of such a thing. And we probably won't get through all of it. We've got 30 minutes to go, but we'll see how we go. So we'll nix the tests. So if we're going to look at something to deal with that concept of, okay, we need to be able to load the next view and then do something with it. Now, we don't really have any way to do that yet, because this update view function, when it loads, it's expecting everything to happen synchronously. So it finds exactly the right one and then runs that render function, bang on, straight away, off we go. We probably can't do that anymore. We have to figure out some way to take these elements and then wait for the result to come from that view. So what I'll do just to start off with is talk about this concept of loading. So for a particular route, we've got a render function, we've got a matcher, and we've got a name. And we'll see, if we look at app.ts, that we've already added these routes here. So these take whatever they're given and they cram a bunch of content into them, and then they're done. Now, what if we added an extra function that just tells it what to do before, what to collect before this page? And now we don't have any actual data to collect. We haven't implemented that system. So what we're going to do instead is introduce just a small delay and then return an answer to that delay. So this function is going to take some parameters. We pretty much have to take those parameters. What I'll do is first, I'll need to make a type for a preload function. So that type for the preload function is simply going to take parameters. And it will eventually take more, but for now, it'll take those view parameters, and it's actually going to return something different. It's going to turn the concept of a promise. And that promise, it can really return any promise, I guess, but eventually we'll have to think a bit more about how that works. And this probably deserves a digression. What the hell is a promise? So when we talk about JavaScript, like a lot of it's about asynchronous code. So here, if we look down at app.ts, this is a piece of asynchronous code. We add an event listener, and then we put a function on it that essentially tells the browser, I want you to call this function once you're done with this content load. And that callbacks can get really hairy once you get enough of them in place. They can be really hard to manage, because you can imagine, like, if you say add another event listener here and that's got a callback, and then you've got several callbacks deep, and eventually you're not necessarily sure of the order of execution. It can become very hard to orchestrate things. A promise uses the concept of callbacks a little bit, but otherwise allows you to work with them in a little bit more of an interesting way. So let's talk about, like, if we just make a small promise, promise. So each promise needs to have inside it a function that resolves or rejects. And this is really just the difference between something good happening or something bad happening. So if we go new promise boolean, am I allowed to do that? Promise only refers to a type. Yes. TypeScript. Sorry, my bad. I need to make sure that my type system is happy. So just give me one moment. I'm just going to go check in another project how I deal with this particular problem, because it is annoying, but it is what it is. Yeah, so because promises aren't all the way supported by every single thing, you sort of need to make it really clear that you want to use promises. So I'm going to add to my compiler options for TypeScript lib ECMAScript 2016. And I believe this should actually be enough to get it to acknowledge the existence of promises. But maybe not. Seems happy with that. That's good. Although it now doesn't like HTML elements, so I think I've probably messed up something else. Let me just check my the TypeScript documentation real quickly. It's not showing me where it is, but yeah, what we were likely missing is a compiler option for our libraries. So that compiler option, yeah, here, we'll find it now. Yeah, so we want the DOM in this as well. There we go. So the DOM is essentially these HTML elements are the types for the DOM, so we need to account for them as well. And it looks like we're missing something else, so let's deal with that. No, we're not. We should be good now. Yep, we're all good. All right, we're back to where we were. All right, let's talk about promises again. So when you create a promise, you give it a function that either has resolve or reject. And the whole idea of this promise is it allows you to do some sort of thing that's asynchronous here. Like, for instance, we could set a timeout. Oh gosh. And we could say resolve, give it the resolve function, and have that happen after 1,000 milliseconds. So that take one second. And that's not, I mean, staggeringly useful as it stands, but what that then allows you to do is stuff like, okay, promise.then then some sort of result from here. So it gives us the result of this function here. It then allows us to do something with that afterwards, and this allows us to chain things kind of nicely. We can go and then result of that do something else, and then result of that do something else, and that construct allows us to sort of tie together a bunch of asynchronous actions without having to think too hard about it. But this will become demonstrated more as we actually use them. So I'm not gonna, yeah, we're gonna launch into how we actually use this. So this preload function, we're expecting that to be in our route path. So let's put that in there. You know what? I only live once. I'm gonna get rid of that capital letter. It bothers me. So we're gonna make a preload function in our route path, a concept of a preload function. And we're going to have to be able to add that down here as well. Right, and we'll put that in our route stack as well. And that should leave us here. So unfortunately, we're missing a bunch of type signatures now. But what we can do is we'll just skirt on through and give these all some sort of promise. So we're going to make some of them load immediately, and we're going to make some of them load with some sort of a delay. So here with this home one, we're going to so this is a different like a sort of a helper that makes a promise that immediately resolves, and that one's going to immediately resolve to true, and that's all very well and good. What we're going to do with the about page is make that have some sort of a delay. So let's give it a delay of so we'll go new promise. Oh my god, the typing tonight. All right, so we're going to give it a new promise. And it's going to set timeout, window.setTimeout rather. And that's going to resolve after 1,000 milliseconds. And then we're going to bump that up even further. For our entry routes. Right. So, having done that, nothing should have changed at this point. We should still be able to run our code and have it work as we expect it to. Which is true. Very good. So what we want to do now is we want, during this update view sort of area, we want to be able to make a delay before this route render happens. And we could do something really naive here. In fact, let's do the really naive thing, and then we'll figure out more from there, because this isn't going to be acceptable down the track. So if we find the right view, what we can do is we can run the preload. With view params. And then do dot then. We don't actually care about the result here, but we will eventually. Oopsie daisy. So we run the result, and then we end up out here. And then we can run the route render inside this here. What's the word? Yeah, we can run the render inside this callback function after the preload has happened. And this should actually give us our little bit of a delay here. So there we go. So that took 3 seconds. You'll notice the home page came immediately, and then about waited. Yep, there we go. So we've got now our little delay. It's a pretty trivial delay because it's not doing anything where it's resulting in some sort of bad thing happening. And we're also not preparing for this transition to take place, which is another slight problem. And therein lies probably one of the bigger issues with transition is we can't actually do this transition if they're both using the exact same sort of area to render themselves. Because usually what happens with a transition is you'll have one view here and one view here. Let's see if I can get in front of the camera here. Yep, you have one view here and one view here. So you click a link on this one here. Eventually, there might be some sort of pre-state happening where you're getting ready for the transition. The new one comes in, and then that's when this one starts to recede away in some way, shape, or form. Or there's some sort of crossfade between them. But either way, you actually need both views rendered separately in order to transition between them. So you can't actually just do them into the same element, if that makes sense. So what we probably need to do is make a container for each one, and so that we can gradually move out from the other one. And that means we're going to have to keep track of a lot more stuff here to actually do this properly. So just for a moment, I'm going to take a think about how all of this container is set up. Because right now we've got this initialize router element here, which creates a route stack. Yeah, where is our initialize function? We should probably put that up the top, really. Let's do just that. So it prepares for updating a view, and it's got this concept here. Yeah, it's got update view, and these functions get called in all sorts of different places. So what we can probably do, we need to have some way to keep track of what the heck is happening all over the app. So let's make a little interface for router state. So when we do this, we sort of need to keep track of the current views that are in action, the one that's on the way out, the one that's on the way in. And I don't want to overcomplicate this too quickly, so let's think about just what our current view is right now, or current route. And that current route is not just the route itself, but also the parameters, because it's important that, like, if we were to change from, say, entry 1 to entry 2, technically you're still changing page, right? You need to have that new load happen in order to get to that new page. So it's important that it differentiates the path. So maybe it's actually better to go current path and just use current path to figure out whether we need to change our view or not. All right. So we'll have a router state, and we'll say what our current path is. We won't actually do anything to start off with because we don't want, we want it to be able to load straight away. Straight away into where it needs to go. I don't feel like I'm doing a very good job of explaining this. So let me take a moment to think about how I'm gonna properly work through this concept. Whenever update view gets called, it needs to know whether it needs to do work. So it needs to know, am I on a new path now? Do I need to load a new view? Do I need to set in motion a new transition? And if so, do I need to use current path? Do I have the data to know whether that's the case or not? So that's what that current path is going to have to serve as a state for. So if I pass in the router state, and I'll just alter the router state every time I do it. And we'll just have a look at how this all comes together. So when we end up in a view, so the current location is this. And the current path is this. So that's probably a misnomer. Let's go loading location. So, or rather loaded location. Because we need to know what we're actually looking at right now. Right, so the whole idea here is if current location equals router state loaded location, we shouldn't need to do anything. We can return. Otherwise, we now set router state to loaded location, or router state loaded location to the current location, and then we go ahead and do our thing. Oh wait, we're on entry, so that's why it's taking so long. Yeah. Okay, so our code still works there because we didn't really make any sort of logic to change how our router is going to work. But now what we want to do is we want to say, all right, so if we're changing our loaded location, now what we need to do is initiate some sort of logic to get rid of the old view, or prepare the old view for getting rid of it, and then prepare the new view, preloading that, and then bringing that in. So we do also need to keep track of sort of the old container, as you will. So let's pull that open. We'll have something for the last container. or the last container, so that we know where sort of our old view is, whatever it is. Yeah, okay. Right, so we've got this idea of a view element, and what we're going to do, instead of writing directly into it like we are now, we're going to make a container for every single view that we put into it. So we'll start off with that, and then hopefully this will start to come to a bit more shape. So when we load a new location, we know that we need a new container for this new view. So let's do just that. We'll create a new element. So so our new view container will we need to create an element. So this is essentially how you create new DOM elements out of thin air. You just use document.createElement, and then after that you need to possibly add some information to it. So we're going to set an attribute on it that just allows us to see what is going on. So data, we're going to set an attribute on it called data route path. And we're going to call that the same as current location. We're also going to store this view container. Actually, no, we won't do that yet. So this new view container is going to be the thing that contains our route. And what I might do is actually run our code just like this, just so you can see what's going to happen as a response to this. Actually, nothing's going to happen to it yet because we haven't put it into the view container. So we need to take the view element and append child new view container. All right, so this one loads immediately. So what's going to happen every time I go to a new place? It's going to load the next page and the next and the next. And you can see how these are accumulating here, these new containers. So what we're going to do is we're going to take that concept of accumulation, and we're just going to make sure that we clean up after ourselves after the new route renders. And then we'll eventually figure out some way to transition these. So what we'll do is we'll take every time it renders, we're going to also add to our router state the last container, and we're going to make it this this new view container. So now this won't change any actual functionality here. Okay, so you can still see this accumulation of all these different views. What we're going to do instead of keeping them around though is once we've done our preload, it's now going to be time that we can actually remove the old one. So if the router state dot last container, so if there is a last container, then we're going to actually remove it. So we need to go to the parent node and then remove child. It's kind of a dance, but anyway. I could probably make that a lot shorter than it is right now, but let's just bear with it for now. So now if we have this little logic here which removes it, then we should end up not accumulating these views anymore. So that's all very well and good, but we can probably go one step further. And then if there is a router state of last container, what I'm going to do, just for now, something really basic and simple, is I'm going to take its style and its opacity and set it to 0.5. You're not going to let me to do that? Oh, it's meant to be applied to a string. There we go. So we'll do that. So now, while it's waiting, it's going to go to opacity 0.5, so I can see that's sort of my loading state or my loading time. And then it's going to go to the next point. And if it's immediate, it's just going to happen immediately. But if it's not immediate, it gives it at least some indication that it is now loading. Now I'm just going to say it's 5 minutes before the end of the stream. So if you have any questions, please send them through. I've been told that potentially my chat is busted, so I'm going to type myself gonna type into the chat myself. Please let me know if you're not gonna receive it. Oh geez, WebSockets is broken on Firefox. Say it ain't so. Oh my, it's my chat that's busted by the looks of it. Even though I did receive something down the track. Let me fix that real quick. Probably hearing a little ad in the background there. My apologies. All right, let's go to the dashboard and see if our chat works when we are in Chrome. All right, I think we'll have a chat that's working now. So if you have any questions, please shoot them my way, and we'll be finishing off in a couple of minutes. Thank you, David, for letting me know about that. All right. So we are good. We now have chat. So yeah, we have this route disappearing as we go. If I open up the inspector, you can hopefully see this taking place. So that one was immediate, so off it went. But here in this one, you can see both views are technically there. Both containers are there. And then it dismisses the other one after a short delay. And you can probably see where we could end up introducing some sort of a... what's the word? We could end up introducing some sort of a transition here, because we could delay this removal just a little bit further. So we could add a const here to store the leaving element, so to speak. So we get that leaving element. And we only remove that leaving element after a short amount of time, potentially. So if we wrap that in a set timeout, which is bad form, we'd definitely use promises and stuff like that. But just for demonstrating the point, so let's give that 250 milliseconds where it hangs around in some way, shape, or form. I don't need that. That's better. So now, if we've got that that brief time of getting ready to get rid of something, you can see here there's some short time where they're both here. So now we've got the blueprint for some sort of an overlap to occur. But that said, I'm going to take that out for now because I don't really want to leave it. What will eventually need to happen is we'll have to have a longer conversation about how we manage route state, how we keep up with how many elements are sort of dancing around the page, because while this is all right, this probably won't be able to play nicely with the fact that I just clicked on 3 different routes. You can see here it loaded each of them and then eventually ended up at the last one I clicked. So we need some way to know that when we're in the middle of these transitions and not let the user absolutely throttle the web app for all it's worth. So we do need to manage this a bit more than we are currently. Maintain some state about whether a load is currently in progress, and whether to allow any sort of interaction in the app while that is happening. But hopefully you can see the direction that this is gravitating towards. Eventually, these functions will be able to form a wrapper around something with some real logic on it. At the moment, there's no logic there, but eventually there will be. And once there is, we'll be able to do this with a little more intelligence. I think that pretty much covers it for today. That brings us to an hour. So we're just going to keep on trucking on with our routing system probably the next time we're on stream. I don't feel happy to sort of leave this and go on to something else. Eventually we will need to talk about our in-memory state, and maybe that will need to interact with the router, so maybe we do need a bit of a digression there, but I'll have a think about that over the next couple of days. We'll be back next on stream on Tuesday at 8 p.m. Australian Eastern Standard Time. If there are any questions that you have, please let me know right now. Otherwise, we'll call the stream at that point. While I'm waiting for any questions that may or may not be made, I'm just going to commit all of the work that we've just done. Alright, so we are on day 3. So yeah, we added support for asynchronous loading of routes with preload functions. Oop, I don't know if I did that right. I made a mistake. Yes, I did. This is where, yeah, that's good. Right. Cool. All right, that is pretty much it from me. I don't think I've got any. Questions. I'm sorry, this is still a bit of drudge work at the moment. Like, it's still not super tidy yet, but we are gradually getting our way there. I'm partially regretting going down the route of routing first, mainly because we do have to probably deal with our application state before we can do our routing properly. But I mean, it's 1.5, 6 eggs on one hand, half a dozen on the other. I think either way, you do have to just get through all of this drudge work to end up being able to write an app. So it is either way what it is. And either way, I'm pretty happy with where we've gotten to in the first 3 hours of the app. There is something important to keep in mind, that this is really only 6 hours into the project if you count the tooling. So you wouldn't feel too bad about getting this done over the course of a day if you were intending to write things from scratch. And we'll just pick it up next Tuesday and keep on trucking. Anyway, thanks for watching. See you next time.